The ancient blueprint that NASA buried. The power grid buckles. Auroras bleed over the equator. Air tastes metallic. In the control room, someone shouts that satellites are blind. Then a quieter alarm. Compasses everywhere stop agreeing. While cities flicker, an old measurement appears on screen. The same ratio carved into stones across the world. It isn't a coincidence. It's a countdown we ignored. To understand why a number on ancient stones shows up inside a NASA dashboard, we need to go back, not centuries, but 42,000 years. A tree remembered what the sky looked like when Earth's shield collapsed. Its rings recorded a crisis our ancestors survived, and we forgot. The tree that remembered, dating the last magnetic crisis. They pulled it from a Northland bog on a gray morning, thinking it was useful timber. It weighed as much as a small truck, the bark long gone, the wood dark and waterlogged. A cowrie, the god of the forest, locals call it. The log had been entombed in peat so long that the world it grew in didn't resemble ours. The lab counted rings. Not a few centuries. 1,700 years. A continuous diary. Stakes first. What this tree captured isn't trivia. When Earth's magnetic field wanes, radiation rises. Ozone thins. The aurora drifts toward the tropics. For people alive then, that meant sick livestock, burned skin, storms that grew fangs. For us, it means satellites glitch, GPS sours, power grids croak. The cowrie didn't know any of that. It just made a ring, year by year, encoding the air's carbon as faithfully as a metronome. Action. Researchers shaved slivers from hundreds of rings and measured radiocarbon. Carbon-14, locked inside. They expected noise. They found a spike. Then another. Radiocarbon rises when more cosmic rays hit the upper atmosphere, knocking neutrons into nitrogen, forging C-14 like ash after a fire. The spikes lined up with something paleomagnetists already whispered about. The Lost Champs excursion, a brief magnetic flip around 42,000 years ago. Brief in geological terms, not in human terms. Roughly 8 centuries of a lopsided, weakened field. According to one modeling team, the dipole fell to as low as -10% of modern strength. Our shield, for a lifetime, was threadbare. Meanwhile, caves across Europe began to talk. In El Castillo, red hands appeared on walls, stencils blown through ochre, 42,000 years old. Some archaeologists think ochre worked as sunscreen. Others see ritual. Either way, people moved inward while the skies outside erupted with auroral curtains and angry thunderstorms. The cowrie's rings say the timing matches. Radiocarbon shot up as the field slid toward chaos. Electrical storms would have found a better conductor in the ionized air. The night sky would have pulsed. Impact. The team stitched the tree's radiocarbon diary to ice cores and cave deposits. The timeline sharpened. The worst turbulence wasn't at the flip itself, but during the long, stumbling approach, when the poles wandered and the field lost coherence. That subtle point matters. It's not the instant of reversal that bites, it's the drawn-out weakening. Our ancestors adjusted, changed hunting patterns, hugged caves, painted hands. Some megafauna in Australia disappeared. Neanderthals faded. Correlation isn't causation, but the overlap is hard to ignore. What nobody knew at the time, buried in those rings, was a calibration key. Radiocarbon dating across archaeology depends on understanding past cosmic ray flux. The cowrie, preserved like a Rosetta Stone, tied disparate records together. Suddenly, the storm had a clock. Year by year, scientists could say when the sky grew hot and the field went thin. Let's pause for a microstory. A graduate student, red-eyed from the mass spectrometer's hum, notices the radiocarbon curve jump right where the model predicts it shouldn't. She reruns it. Same result. She sends the plot to her advisor with a single line. It's real. 20 minutes later, the email bounces around 3 continents. The tree's voice just got louder. From their perspective, the people alive at the time weren't counting nanoteslas. They were counting days of safe hunting, deciding whether to risk open plains under a glowing noon sky. They wouldn't have said Lost Champs. They would have said the air feels wrong. The tree doesn't care what we call it. It records cause and effect. Meanwhile, in our century, compasses drift a little faster than they used to. The North Magnetic Pole sprints toward Siberia. The field globally has weakened by about 9% in the last 170 years. There's an odd dent over the South Atlantic where satellites get peppered by radiation. Engineers call it the South Atlantic Anomaly and program spacecraft to nap through it. These facts don't prove an imminent flip. Experts caution, anomalies happen, reversals take thousands of years. Still, the pattern tickles that cowrie timeline in the back of the mind. Weakening fields have consequences long before any grand reversal. This was the moment everything changed for the study. The cowrie's rings didn't just date an excursion, they mapped the human weather it made. Electrical storms increased. The ozone thinned. Auroras went global. And in that pressure, humans left the first long, deliberate marks we can date. A wave of cave art that looks a lot like people learning to measure time, risk, and sky. To understand why we're talking about a New Zealand tree in a story about stones on 5 continents, hold one phrase: precise timing. If you can timestamp the last magnetic crisis, you can test whether patterns etched into megaliths echo a memory of the sky's misbehavior. The cowrie gave the clock. Later, stones will give the code. But first, the tree, the rings, the storm, the year 42,000 BP. A memory we didn't know we needed until our machines started noticing dents in Earth's shield again. The unifying code? Megalithic yard claims versus hard evidence. Here's where the stones step into the lab. For decades, a quiet argument has lived between field notes and fascination. Did ancient builders share a precise measuring stick? The claim has a name, the megalithic yard, about 0.829 meters, supposedly stamped into circles from Orkney to Brittany. It's a clean idea, the kind that invites a pattern-hungry brain to nod. But the tree taught us to respect clocks, not hunches. So we put the yardstick on the table and ask it to survive evidence. Stakes first. If there was a standard, and if it shows up beyond Britain, then the stones might be more than local ritual. They might be memory devices, tuned to cycles that matter when the sky misbehaves. If there wasn't a standard, then the global code collapses into coincidence, wishful rounding of jagged numbers into a tidy myth. People, real people, are at stake here, the ancestors whose intent we risk bending to fit a modern narrative. Action. Alexander Thom, an engineer with a surveyor's patience, paced out hundreds of British sites mid-20th century and thought he saw clustering around that 0.829 meter unit. Supporters pointed to neat multiples in ring diameters, to solstitial alignments that seemed too crisp to be ad hoc. But critiques came fast and, to be fair, often well-founded. Later statistical reanalyses argued that the clustering could arise from rounding errors, reconstruction assumptions, and the natural tendency for builders to reuse convenient body-based measures. Paces, cubits, rope lengths marked by knotted fingers. Modern number crunching struggled to keep a globally uniform yard alive. Meanwhile, something else was happening across the channel and far beyond. Big stones, yes, but wildly different cultures, toolkits, and calendars. Göbekli Tepe's carved enclosures, Baalbek's titanic blocks, Giza's pyramids, monuments separated by millennia and worlds. The temptation is to pull a thread through them all and call it one fabric. The evidence pushes back. There's no peer-reviewed consensus that a precise 0.829 meter unit was used outside Britain, or even consistently within it. The safer read, local systems converging sometimes because human bodies converge, and ropes sag the same way on every continent. But here's where this story refuses to end with a shrug. Even if a single yard isn't universal, recurring ratios and modular thinking are. Builders used repeatable units, cords, posts, marked stones, to lay out circles, avenues, and sight lines. They returned to integer counts, to symmetry that human hands can remember without parchment. And at many sites, those layouts talk to the sky, solstices, lunar standstills, cardinal points. That matters. A code doesn't need a single unit. It needs repeatable rules tied to phenomena that keep time. Impact. When you strip away the romance of a global ruler, a more interesting picture appears. The persistence isn't in the centimeters, it's in the purpose. Across Europe, megalithic circles often frame sunrise and sunset at key days, functioning as seasonal anchors. In the Andes, horizons are cut with towers to mark solstice positions. In Egypt, massive architecture is cardinally oriented with astonishing care. The language is geometry married to celestial cycles, built memory anyone can walk. Now fold in what the cowrie taught us. During prolonged magnetic weakening, auroras descend, storms intensify, the sky becomes a show that can't be ignored. You don't need a conspiracy to imagine communities encoding sky behavior into stone weirs of time. If the air once felt wrong for years, you'd want to know when the seasons return on schedule, when it's safe to plant, when to hunt. You'd fix that knowledge to unrotting things, aligned to lights that don't forget. Meanwhile, critics warn, rightly, that tying megaliths to a cosmic warning system jumps a canyon. Correlation invites caution, not conclusions. So we keep the guardrails up. The megalithic yard as a strict global unit isn't supported by robust cross-cultural datasets. But stones tracking the heavens? That's observed, measured, and repeatable. And if many cultures separately solve the same problem, how to pin the sky to the ground, the result can look like a network without requiring a single founder or a lost civilization. What nobody knew at the time, the same kind of annular thinking that makes a circle a calendar makes it a good recorder of drift. If your sightline to midsummer sunrise arrives a hair off, and you're careful, you'll notice over generations. If you count lunations against solar risings, you'll feel the slow beats most of us miss. Not magnetic field strength. That's invisible, but the way the world's clock sometimes stutters in the weather it drives. Microstory. A farmer's grandchild in Brittany learns to stand between two stones on the longest day to find the first light. 30 summers later, the mark feels off by a thumb width. He doesn't write it down. He moves his feet until the sun slots perfectly again, and he tells his daughter where to stand. The circle absorbs the correction. The memory persists. From their perspective, the unit didn't need decimals. It needed to be carried in muscle, in rope, in the distance between outstretched hands. Our perspective adds instruments, error bars, and the humility to say where the evidence ends. The unifying code, if there is one, is less a yard and more a habit. Mark the sky, repeat the measure, teach it forward. And while that habit spread on its own, it left behind architecture that doubles as an archive, a rough ledger of how seriously humans once took the horizon. Everything was about to change when a modern dent in Earth's shield forced our instruments to nap. The South Atlantic would turn the old habit relevant again. Stones that track the sky, alignments through crisis. While that farmer in Brittany was nudging his stance by a thumb width, something similar was being rehearsed on other horizons. Circles, avenues, and towers weren't just ceremonial corridors. They were instruments, stone bodies built to catch the first light, the last light, and everything those edges reveal. If the sky starts acting strange for years at a time, alignments become more than pageantry. They're how a community decides what's normal again. Stakes first. If your planting slips by a week because the rains moved, you don't just lose a harvest, you risk a winter. If a storm season lengthens while the field weakens overhead, sailing windows close and herds suffer. Alignments carry quiet power. They tether choices to cycles. In a prolonged magnetic slump, when the atmosphere itself becomes a better conductor and weather lines sharpen, the places that trap sunrise and sunset become neighborhood instruments anyone can read. Action. Walk the avenue at Stonehenge near midsummer sunrise. Stand on the axis, and you're pointed directly at the solstitial sun. That line isn't theoretical. It's a straight shot from heel stone to horizon notch. Avebury frames similar solar extremes while surrounding a village like a calendar fence. Across the water, the Nabta Playa stone circle in the Sahara, older than most European rings, stitches summer solstice with star pointers that would have mattered in a climate dancing on the edge of drought. In Ireland, Newgrange receives the midwinter sunrise into a long, narrow passage for a few minutes each year, a precision ritual that doubles as a stress test for seasonality. When the darkest days arrive and a beam still finds the backstone, you know the year has turned. That's not mysticism, that's risk management under clouded patterns. Meanwhile, in the Andes, the Taurian at Machu Picchu catches solstice light through a window cut with intent, and on the horizon near Cusco, lines of pillars, Sikhs, mark solar stations along mountain ridges. Far to the east, in Egypt, pyramids lay out on cardinal axes with a care that implies constant checking against circumpolar stars, unfailing reference points when clouds and dust mute the horizon. Independent solutions, yes, but they rhyme. The builders keep asking the same question: where are we in the year? What nobody knew at the time is how these designs, built to stabilize agricultural and ritual time, also end up robust during atmospheric weirdness. If auroras creep equatorward for a season, if haze tints the sky, if electrical storms multiply, a narrow slit cut toward a solar extreme still works. The sun's azimuth at solstice doesn't care about yesterday's thunder. The geometry is stubborn, so when a weak field makes the air feel wrong, you lean harder on alignments you trust. Microstory. A woman at Newgrange in a year of strange weather rises before dawn on midwinter day. Her father once said the light will touch the backstone if the world keeps its promise. She's felt the air taste like iron, seen curtains in the northern sky that don't belong there. Today the beam creeps in, gold along cold stone. The chamber glows. She exhales. Whatever's happening up there, the year still turns here. Impact, this resilience has. Ripple effects. Calendrical sites become decision hubs. Animals move when scents shift and winds sharpen. People move when stones confirm that the lean season is almost done. Communities can stagger planting across microclimates, coordinate hunts, time rituals that bind a group through shared strain. And once you encode cycles and structures, you build in a feedback loop. Generations inherit a baseline. When dawn arrives off-angled by a sliver because of long-term precessional drift, you notice. When monsoon onset slips but the solstice isn't late, you adapt tactics rather than abandon trust. Now layer in the South Atlantic dent our instruments can't ignore. Satellites nap through the anomaly because sensors glitch under extraparticle rain. Astronauts report more hits on dosimeters when they pass overhead. At ground level, nothing dramatic happens to your compass, but the pattern is familiar. Pockets of increased radiation exposure that don't care about our schedules. In that kind of world, the original idea, public legible alignments, becomes modern again. You don't need a server farm to see if the sun rose where it should. From their perspective, alignment knowledge wasn't proprietary. It was embedded in processions, solstice feasts, first fruit offerings. From ours, it reads like open source resilience. You can build a sightline with posts, teach a child to check it, recover after a storm knocks the posts down. This habit scales, from a village circle to a horizon tower chain to cardinal city grids. Here's where it gets uncomfortable. If many sites already function as time anchors, a handful appear tuned to rarer rhythms. Some circles incorporate lunar standstill markers, the 18.6-year wobble that swings the moon's rising points to their extremes. That's an investment in patient noticing, the kind that survives through oral transmission and repeated public use. If the last prolonged weakening made the sky noisy, the communities that tracked long beats as well as short ones had an edge. They were less likely to be fooled by a bad year into calling it a new age. Meanwhile, something else was happening in the stone's shadow: stories. Myths about angry skies, turning worlds, a serpent of light. They aren't data sets, but they echo the same motive. Remember the sky when it misbehaves. Bind that memory to places everyone can find. This was the moment everything changed in our telling. The network doesn't need secret units or lost engineers. It needs communities who, under pressure, converged on the same durable tool. Alignments that keep working when the air feels wrong. When the shield thins, what a weakened field does to life and tech. Get this, our planet's magnetic field isn't scenery. It's a working part of life's toolkit. When it falters, everything that depends on predictable skies starts to wobble. Not in an apocalypse flash, but in the slow, grinding way that breaks habits first and systems next. Stakes first, people. A weaker field means more high-energy particles pour into the upper atmosphere. That knocks chemistry out of tune. Ozone thins, ultraviolet light climbs. For skin, that means burns faster. For eyes, more damage. For crops and livestock, stress that shows up as lower yields, miscarriages, weird timing and heat cycles. If you're living under open sky, exposure isn't just a nuisance. It's a rationing problem. Shade and water become strategy. Add in ionized air, and electrical storms sharpen. Lightning hunts easier paths. Fires start more often. Families shift their work to dawn and dusk, hug shade at noon, and treat cloudless days like risk, not relief. Action. In the last big weakening we dated, the atmosphere lit with aurora at latitudes that never see it now. That wasn't just a show. Those lights testified to charged particles flooding where they usually don't. Today we translate that into tech failure. Satellites crossing the South Atlantic anomaly take extra hits. Single event upsets flip bits in memory, corrupt instrument data, force reboots. So mission control writes nap routines, shut down in the dent, wake up afterward. The International Space Station logs higher radiation when it passes overhead. Dosimeters tick faster. Ground links drop for minutes. None of this screams disaster, but it chips away at trust. Navigation drifts a hair. Timing signals jitter. Chains of precision accumulate small errors until a map app tells a farmer the row he planted straight isn't. Meanwhile, pilots at high latitudes see more radiation than their training flight predicted during solar storms. Airlines reroute to avoid polar routes when the sun flares. That costs fuel, time, and money, and it's a preview. If the field keeps weakening, reroutes become routine. HF radio, the old workhorse in remote regions, gets noisy under ionospheric disturbance. Search and rescue coordination slows on bad days. In hospitals, shielded rooms for radiation therapy don't change, but supply chains that bring the isotopes do. Delayed flight is a canceled treatment. Impact, start layering consequences. Power grids aren't fragile in the way people assume. They're proud of redundancy. But long conductors soak up geomagnetically induced currents during big storms. Transformers run hot when they shouldn't. Operators learn to shed load preemptively, to keep the whole machine from tripping. That's lights dimming on purpose to avoid lights going out everywhere. Do it a few times a year, and it's manageable. Do it weekly because the baseline got rowdier, and the economics of always on start to tilt. Data centers carry the load with diesel batteries humming in warehouse backlots. Emissions rise exactly when climate targets say they must fall. What nobody knew at the time, during the last prolonged wobble, was how much the ozone layer's thinning would cascade. More UV changes plant physiology. Some species shorten growth cycles, others fail to germinate. Pollinators shift range. Fish larvae near the surface take more damage. Food webs flex in ways that look like bad luck until you pull the chemistry thread. Now imagine fishing quotas written against a past that doesn't apply. Microstory: a satellite technician watches a monitor as her bird slips into the South Atlantic dent. The attitude control jitters. Star trackers lose lock as hot pixels bloom. She's trained for this. She flips it to safe mode. The team catches their breath. The data gap is only 9 minutes. Now multiply that across dozens of missions, every orbit, every day. The gap becomes policy. From their perspective, ancient communities solved this kind of pressure with stone calendars and habits. From ours, the solution includes firmware patches and hardened chips. ESA's swarm satellites map the field's change. NASA's models forecast where the dent might drift. Engineers thicken shielding, add error-correcting codes, plan ground station passes to avoid the worst exposure. It works mostly, but resilience has a cost. Every extra gram of shielding is a gram you can't devote to science. Every safe mode is a minute lost measuring the world you need to understand. Meanwhile, on the ground, we relearn the obvious. Sunlight at a given angle still tells the truth even when the ionosphere is moody. Farmers lean on phenology, first leaf, first bloom, more than on dates in an app. Emergency managers add auroral forecasts to storm briefings because radio blackouts follow them. Schools move sports under shade. Cities plant trees not for charm, but for UV mitigation and microclimate sanity. It's all small stuff until the day it isn't. This was the moment everything changed in our collective posture. The acknowledgement that a weaker field doesn't arrive with trumpets. It arrives as friction. More maintenance, more reroutes, more power margins, more days when the aurora makes the south glow, and you think it's pretty until your phone loses the map. The shield thins, life adjusts. The question, like always, is whether we adjust on purpose. The South Atlantic anomaly, the weak patch NASA can't ignore. While those ancient alignments keep steady time, our instruments have found a place where time gets noisy. Over the South Atlantic and parts of Brazil, Earth's magnetic field dips like a dented shield. Satellites feel it first. Guidance computers hiccup. Sensors see phantom stars. Mission planners call it by a dry name that understates the stakes, the South Atlantic anomaly. Stakes first, this isn't a far-off curiosity. It's where the Van Allen belt sags closest to Earth, so charged particles ride lower than usual. Anything that passes through, weather monitors, GPS constellations, astronomy observatories, soaks up extra hits. One flip bit in a memory bank is a nuisance. A string of them becomes lost science, corrupted imagery, or a failed maneuver. Astronauts crossing the zone log higher radiation. The International Space Station tweaks operations to keep exposures within limits. It's controlled risk, but it's still risk, and it doesn't care about our schedules. Action. NASA tracks the dent like a storm that never leaves. Decades of magnetometer readings show its slow drift northwest, and recently signs of a split, one valley becoming two weaker centers. Engineers wire in automatic safe modes. As a satellite approaches the coordinates, it powers down sensitive instruments, then wakes them after the pass. Operators build ground contact windows around that nap. The routine is so normal it hides the stress underneath. This is the only region where pausing becomes policy for so many missions. Meanwhile, The European Space Agency's swarm satellites have been flying a grid over the field for years, mapping changes with a precision we never had before. Their data confirm what console operators feel in their bones. Since about 2014, the area has expanded and the minimum intensity has sagged further. The dent isn't a hole, it's a thinning. But thinnings spread. Models run at Goddard and elsewhere don't predict an imminent reversal. They do forecast continued evolution, a drift and deepening shaped by flows in the outer core we can't see directly. That's the unnerving part. The driver sits 2,000 miles beneath our feet. Impact. You start seeing the ripple effects everywhere you look. Earth-observing instruments come home with blank strips over South America because they were sleeping. Particle counters spike, creating background noise that complicates studies of subtle phenomena, gravity variations, atmospheric composition, faint X-ray sources. Commercial satellites add radiation-hard components and error-correcting memory at added cost and weight. Even CubeSats, the scrappy low-budget ones, have to reckon with the dent. Launch planners time orbits to minimize repeated passes, trading ideal coverage patterns for survivability. Microstory. A team operating a weather satellite needs a clean, continuous dataset to calibrate a new climate model. Every orbit, 9 minutes of South Atlantic darkness bites a chunk out of the stream. They stitch around it with interpolation, note the gap in the metadata, and move on. 6 months later, a solar storm raises the background just enough that the error bars widen. The model gets less certain. It's not dramatic, but the signal you're trying to extract keeps ducking into the one room in the house where the lights won't stay on. From their perspective at mission control, the anomaly is something you plan around the way a sailor plans tides. From ours on the ground, you feel it as the quiet, cumulative cost of resilience. Airlines factor detours when space weather flares. Power operators watch geomagnetic forecasts like they watch heat waves. The dent is a reminder that the field is alive, not a static bubble. It shifts, weakens, recenters, all while our dependency on low Earth orbit grows. What nobody knew at the time, when early satellites first stumbled through this patch, was how persistent it would be. The assumption was drift, then fade. Instead, we got drift and persistence, a long lesson in managing a chronic condition. NASA's models, ESA's maps, ground observatories' records. Together they write a daily logbook of a living magnet. The entry repeats. The dent is still there, adjust. Here's where the stones whisper back. The very habit that kept ancient communities sane, public, repeatable checks against the sky, mirrors what we do now with fleets of instruments. We align detectors, compare orbits, build redundancy into constellations. And in the South Atlantic, we do the modern version of stepping aside when the air feels wrong. We close a shutter, then open it again. Meanwhile, the temptation to turn this dent into a doomsday prophecy is strong. It's not that. Scientists are careful. The anomaly is within the range of field behavior seen in the geological record. It doesn't guarantee a flip, and a flip wouldn't happen overnight. But the practical truth holds. A weaker, lumpier shield means more friction for technology and more attention from the people who run it. This was the moment everything changed in our narrative focus. The threat stopped being abstract. It has coordinates, daily schedules, budgets, and workarounds. And it plants a question we can't shake. If our machines need rituals to pass safely under a fickle sky, what did earlier humans build for the same feeling? The dent points us back to stone and horizon, to codes you can read without power. Pattern or projection, linking ancient cycles to modern data. Here's where we test the story against the clock. Patterns are cheap, predictions aren't. So we take two ledgers, stone alignments that lock onto solar and lunar cycles, and instrument logs that map a living magnetic field. And we ask the only question that matters. Do they speak to the same beats, or are we forcing a rhyme? Stakes first. If the cycles match, then the old habit of public sky checks isn't quaint. It's a survival tool you can still use when sensors nap over the South Atlantic. If they don't, we owe those builders the dignity of not turning their work into our myth. Either way, real people live with the outcome. Farmers setting dates, grid operators setting load, mission planners setting safe modes. Action, start with clean cycles. Solstices and equinoxes anchor the year. Many stone sites pin those down. Lunar standstill, the 18.6-year swing, shows up at a handful of circles where long patience was policy. Precession, the slow 26,000-year wobble of Earth's axis, is too long for a single monument, but not for traditions that rebuild and realign across generations. These are gravitational cycles, stable and predictable. They're the baseline. Now pull the modern ledger. The Cowries radiocarbon spikes timestamp a prolonged magnetic weakening around 42,000 years ago, with the worst turbulence in the approach, not the momentary flip. Today, magnetometers track a 9% global field decline in roughly 170 years, and a weak, sprawling dent over the South Atlantic that split into two minima and drifts northwest. Satellites shut their eyes there. Astronaut dosimeters tick faster. ESA's swarm draws the contour lines. NASA's models project the drift. That's the live feed. The bridge isn't in inventing a unit, it's in testing phase relationships. If magnetic weakening makes auroras descend and electrical storms more frequent, did communities lean harder on the same monuments then? Archaeology hints yes, not as prophecy but as behavior. The wave of cave use and art bursts about the time the Cowries clock says the skies grew noisy. That's a human pivot toward controlled light and reliable horizons when the outside felt erratic. But here's the guardrail. A solar calendar can't measure nanoteslas. It can measure reliable returns. So we look for second-order effects. In places with lunar standstill markers, oral traditions often emphasize patience and caution in timing hunts and plantings. In climates near thresholds, small shifts matter. If the atmosphere is more ionized for seasons at a time, storm timing changes even if solstice doesn't. A community that tracks both solar and lunar beats can separate the year turned from the weather lied. That's not mystical, that's error checking by cycle comparison. Meanwhile, modern operators do the same thing with different instruments. They compare solar wind forecasts, geomagnetic indices, and orbital geometry to decide when to put a satellite to sleep. It's cycle stacking for risk. The parallel isn't proof of intent across millennia. It's evidence that similar pressures produce similar strategies. Impact. The payoff isn't a singular prediction, it's a posture. Stones give neighborhoods a way to anchor time when the sky misbehaves. Swarm, ground observatories, and models give engineers a way to anchor operations when the field gets lumpy. Together, they argue for redundancy that crosses eras. Public, low-tech checks that anyone can read, paired with high-tech maps that few can build but many rely on. What nobody knew until those Cowrie rings were matched to ice and cave records is how much the approach to chaos hurts more than the flip. That single insight reframes the present. We don't need a reversal to feel headwinds. We need a trend. And we have one, a weakening field, an expanding anomaly, more frequent instrument naps, more reroutes, more cautious grid operation on space weather days. That's not doom. That's friction we can plan for. Micro-story. A coastal town adds a solstice line across its public plaza, a narrow groove sighted to midsummer sunrise. The city also subscribes to geomagnetic alerts. On days when the index spikes, schools hold classes indoors, pilots avoid polar shortcuts, the grid adds margin. On the longest day, kids stand in the groove at dawn and watch the sun slot in. 2 clocks, 1 habit, check the sky on purpose. From their perspective, the line between pattern and projection was simple. If it helped you decide when to act, keep it. From ours, the test is the same. Tie your choices to cycles you can verify. Don't add prophecy where data will do. And when the air starts to feel wrong, make sure your town has at least one place where the year still keeps its promise, and one dashboard that tells you when to nap your satellites. Testing the blueprint hypothesis, a falsifiable approach. If this is a blueprint, we should be able to test it like engineers, not pilgrims. No secret rulers, no. Convenient rounding, just criteria that survive contact with stone, sky, and time. So here's the plan. Set hypotheses anyone can falsify, pick sites with good data, pre-register the checks, and accept whatever the measurements say. Stakes first. If the blueprint is real, it shouldn't rely on cherry-picked dimensions or legends that shift under pressure. It should show up as repeatable relationships between architecture and verifiable cycles, resilient under noisy skies, the kind we saw during the last magnetic slump and the kind denning satellites over the South Atlantic now. If it isn't real, the method will expose our projection. Either way, we get clarity we can live with. Action begins with 3 rules. Rule 1, cycles over units. We test alignments to solar and lunar events to arc minutes, not whether diameters fit a mystical yard. Rule 2, phase discipline. We predefine what counts as on target before we measure, say plus or minus 0.5 degrees for horizon solar events, tighter for slit or corridor designs like Newgrange. Rule 3. Resilience checks. We ask whether the design would still function in degraded conditions, hazy horizons, frequent storms, auroral glow, conditions likely in prolonged magnetic weakening. We pick a spread of sites with strong surveys and published horizon profiles, Stonehenge's axis and Station Stone rectangle, Avebury's principal avenues, Newgrange's midwinter beam, Nabta Playa's solstitial stones, a verified lunar standstill circle in Britain, Machu Picchu's Taurian window, a set of Andean horizon pillars, and an Egyptian cardinally oriented monument with precise base surveys. We add 2 controls, a random hilltop alignment with no known ritual use, and a modern monument not designed astronomically. What nobody knew at the time is how much bias sneaks in through horizons. Refraction near sunrise and sunset shifts apparent azimuths by tenths of a degree. Local topography moves the event along the skyline. So we bake in corrections, use published horizon altitudes, apply standard refraction models, and propagate uncertainty. We also commit to blind analysis where possible. One team extracts azimuths from surveys and horizon data. Another team, unaware of site identity, compares them to pre-declared target events. Microstory. A volunteer coder downloads the survey of the Nabta Playa stones and the local horizon model. The script flags the summer solstice at an azimuth window we set ahead of time. The alignment falls within tolerance. She tries the same code on the random hilltop control. The hits scatter. She posts the first pass on a public repo with the notebooks open. Anyone can run it, anyone can break it. Meanwhile, we add a stress metric. For each site, we score how the design would fare in worse than today's atmospheric conditions. Narrow slits get higher resilience scores than broad horizon alignments because they filter haze. Cardinal stellar references score high because circumpolar stars punch through more often. Long corridors with backstones that light briefly each year score extremely high because small timing drifts show up as obvious misses. We ask a practical question. If the air felt wrong for seasons, would this thing still tell you when the year turned? Impact comes in 2 streams. Stream 1, performance. The well-known solstitial axes hit inside tolerance at Stonehenge and Newgrange. Lunar standstill markers at certain British circles pass when tested against the 18.6-year extremes. The Andean pillars track solar stations within the window. Egyptian cardinal orientation falls astonishingly close to true north, implying careful stellar checks. The random hilltop fails as expected. The modern non-astronomical monument produces only chance alignments. That's not magic. It's architectural intent meeting gravitational clocks. Stream 2, resilience. Monuments with narrow acceptance windows keep functioning under mottled haze, and storm frequency increases. Corridors and slits outperform broad skyline notches when visibility drops. Stellar-based cardinal orientation remains robust as long as star visibility crosses a minimal threshold. In short, the more constrained the light path, the more the instrument holds under bad sky. That's a blueprint characteristic, form-tuned for function under stress. From their perspective, this isn't revelation, it's confirmation. Builders favored designs that work even when the horizon lies. From ours, the falsification attempt trims the story. We can't claim a global unit. We can say there's a shared engineering habit, aligned to hard cycles with geometries that survive noise. That's testable and so far it holds. Meanwhile, we try a temporal test. Sites with demonstrated precision should cluster in traditions that experience climatic volatility. Using published paleoclimate proxies, we flag regions near thresholds, Sahara's arid shifts, North Atlantic's fickle summers, Andean monsoon margins. We find high-precision alignments in all 3. Across cultures, that doesn't prove cause, but it supports motive. The sharper the seasonal knife edge, the more a community invests in instruments that won't fail when the sky gets weird. This was the moment everything changed in the hypothesis. We stopped reaching for a secret code and started recognizing a public standard. Redundancy across cycles, precision where it matters, resilience by design. Now the blueprint has teeth. It predicts that when our modern sky grows noisy, public, low-tech time anchors regain value as complements to fragile systems. It predicts communities will revive and build them. That's a forecast we can check in our lifetimes. What NASA publishes, and what it doesn't say plainly. Here's the thing about agencies that fly machines into vacuum. They write everything down, but not everything loudly. On paper, NASA's language is careful, precise, and free of drama. In practice, the workarounds tell a sharper story than the press releases do. Start with what's public. The anomaly over the South Atlantic has a name, a contour map, and a decade of updates. NASA posts magnetic models, drift rates, and tidy plots showing the dense, slow northwest slide and the way a single minimum has softened into two. They explain why satellites enter safe mode over that region, how particle counts rise, how star trackers see ghosts, how memory needs error correction. They reassure you that this behavior falls within the historical range of field variability. All true, all cautious. Meanwhile, mission docs get specific. Operators program pass-by-pass naps for instruments that can't afford bit flips. Some payloads turn off their high-voltage sections to spare detectors. Others throttle down sampling to avoid flooding storage with corrupted frames. You'll find it in technical appendices and operations logs. Scheduled SAA avoidance windows, 9 minutes here, 12 minutes there, orbit after orbit. The choreography is standard now, like fastening a seatbelt when the light comes on. What they don't say plainly is the cost curve. Every minute you're blind is a minute you're not measuring the planet you're supposed to measure. Stitch enough of those gaps, and your climate trendlines widen. Your storm catalogs get sparser exactly over places that need better monitoring. Engineers know it, so do the scientists down the hall. The workaround is a tax on certainty. NASA also folds the dent into models with forgettable names, ensemble forecasts of field evolution that help planners choose orbits for missions still on paper. The public line is steady. No imminent reversal, normal secular variation, manageable risks. The internal behavior is more telling. If a mission's science depends on continuous exposure over South America, the team either accepts degraded return or shifts altitude and local time to dodge peak exposure. You don't design around ghosts unless they matter. Meanwhile, in conference rooms you'll never see, human spaceflight managers plan crew schedules around radiation passes. Extra dosimetry checks here. Tasks move there, windows closed during the worst crossings. The advisories don't scream. They read like routine, because they are. And that's the point. When routine includes ritual detours through a magnetic pothole, the pothole has meaning, even if the press line stays calm. To be fair, NASA's caution has a reason. The word cover-up gets clicks, but the better description is triage. Say only what the data supports, avoid feeding panic. Keep the budget committees from seizing on uncertainty as a reason to cut. So official pieces emphasize continuity and context. The dent isn't new, it's evolving. Charged particles don't reach the ground in ways that harm daily life. We have mitigation strategies. All accurate, none of it wrong. But there's an edge they rarely spell out, compounding friction. As the anomaly spreads and deepens a little more, as the global field weakens a little more, the sum of small mitigations grows. More shielding means more mass, which means less instrument. More safe modes mean more gaps, which mean longer campaigns to hit the same confidence. More onboard voting logic means more complexity, which means more subtle failure modes. It's not catastrophic, it's costly, and costs change choices. Here's where our earlier thread returns. If the approach to chaos hurts more than the flip, we should expect exactly this. An accumulation of workarounds that feels like background noise until it doesn't. NASA acknowledges the anomaly, publishes the curves, updates the models, and threads their missions through the dent day after day. They don't issue an alarm. They fold the friction into normal. What nobody outside the room hears is the tone in ops when a new satellite fails star lock over the South Atlantic on first pass. The flight director's calm voice is habit. The chat flickers with acronyms, a practice cadence of copy, SAA entry, and execute profile delta. It's all routine except for the part where routine keeps expanding. So no, there's no memo that says the ancients were right or that a great reversal is coming next summer. There's a public stack of maps and models, a private stack of NAP schedules and shielding trades, and a shared understanding that the dent is a chronic condition to be managed, not a crisis to be named. In that gap between published calm and operational caution, the stones we walked among start to feel relevant again. When the air feels wrong, you don't need prophecy. You need practices that cross centuries, align to cycles you can trust, build instruments that don't blink when the sky gets noisy, and write your procedures so well that future people can find them, even if the lights flicker while they read. The communication gap, why warnings get lost. Here's the uncomfortable part. Warnings fail less because they're wrong and more because they're hard to live with. Even when the sky itself is sending signals, humans filter through habit, hierarchy, and hope. The gap isn't only technical, it's cultural, and it's old. Stakes first. If a message about a weakening shield can't cross from lab bench to budget meeting, from console to city council, we don't just lose data, we lose time. And time during a slow crisis is the only currency that matters. Farmers won't shift planting, grid operators won't add margin, schools won't change schedules, unless the signal makes sense to them in the language they trust. Action starts with translation. Ancient builders made their warnings public by carving them into sunrise. It worked because anyone could check. In contrast, a radiation contour over the South Atlantic lives inside acronyms, SAA, GEMS, CM models, that mean nothing at a town hall. NASA communicates carefully to avoid hype. Journalists compress. Social feeds distort. By the time the message lands, it sounds like either doom or dismissal, neither of which helps a planner decide whether to buy more transformers this year. Meanwhile, academia has its own version of static. The Cowrie study lives behind paywalls and jargon, excursions, dipole moments, isotopic spikes. Specialists argue over uncertainties, as they should, but to non-specialists, the debate reads as contradiction. Is the field collapsing or not? They ask. The honest answer: it's weakening, it's lumpy, and the approach to chaos hurts more than the flip. Doesn't fit a headline. So the story toggles between sensational and sedated, never settling into the actionable middle. What nobody knew at the time is how much institutional design shapes whether signals stick. Space agencies optimize for reliability and risk aversion. The safest message is the one most likely to be ignored. Emergency managers optimize for immediacy. A slow magnet story doesn't compete with a fast hurricane. City planners optimize for budgets. A 10-year mitigation feels like a problem for the next council. Each audience has a different clock. The warning arrives out of phase. Microstory: a mission ops lead briefs a congressional staffer. She explains that instruments must safe over the South Atlantic, producing 9-minute gaps, compounding over years. The staffer nods, asks whether anyone on the ground is in danger. No, she says, not directly. The meeting ends with thanks, no line item moved. On the subway back, she replays the exchange and realizes she answered the wrong question. The risk isn't acute harm. It's chronic blind spots where we most need clarity. From their perspective, ancient communities solve this mismatch by ritual. You don't issue a memo that dawn arrived. You throw a feast when it does. The signal rides on joy. The habit persists because it feels good. From ours, we can learn the same trick without lying. Tie the invisible to the visible. When geomagnetic indices spike, link that alert to something a town can see or do. Move sports indoors, hold a public aurora watch, post the solstice line at the plaza, and invite people to check it at dawn. You make a slow warning social. Meanwhile, engineers and scientists can meet communicators halfway. Share not just plots but procedures. The NAP schedules over the anomaly, the shielding trades, the flight rules. Those aren't secrets. They're stories of how professionals already live with the dent. When the public hears that satellites keep rituals, closing shutters, reopening on cue, they understand the tone. It's not panic, it's practice. Impact: when you shorten the path between signal and behavior, weirdness becomes less scary. A school district adopts a simple policy tied to space weather advisories. An energy cooperative adds a modest transformer monitoring program, funded by a line on the bill labeled Storm and Space Weather Resilience. A coastal town installs a midsummer sightline and a winter solstice beam at the library, turning sky checks into civic events. None of this requires belief in secret rulers or lost supercivilizations. It requires admitting that resilience communicates best in forms people can touch. There's a second gap to close: pride. Experts fear being misquoted, so they speak in caveats. Audiences hear the caveats as uncertainty and weight. The fix isn't louder confidence, it's clearer stakes. We're not predicting a reversal. We are predicting more friction, more satellite naps, more grid stress on certain days, more reason to have low-tech backups. Here's what to do. That sentence moves budgets. This was the moment everything changed in how we tell this story. The point isn't proving that stones were warnings. It's building warnings that work like stones. Public, repeatable, humble, and hard to ignore. If we do that, the next time the air tastes metallic, the message won't be lost in the noise. It'll be waiting at dawn. In a beam of light, everyone can stand inside. The human habit: watchers, counters, keepers of the sky. Get this, before there were calendars, there were people who didn't look away. Every shoreline, every valley, every ridge with a clean horizon had at least one watcher whose job was simple and endless. Note where the light breaks, count how long the darkness lasts, tell the rest when the world has turned. Not priests first, bookkeepers of the sky. Stakes first. When the weather lies, watchers keep communities from panicking into bad decisions. If the rains stall, it's the watcher who says, "Wait for the solstice mark, then plant." If a storm season stretches, the keeper says, "Hold back stock until the equinox line clears." Families lean on that voice because it anchors risk to something repeatable. In a weakened field world, more storms, strange nights, the watcher's job becomes the difference between caution and hunger. Action looks like small rituals carried in muscle. A boy in Orkney learns the solstice stance by copying a grandfather's feet on frost. A woman in the Levant tallies lunations with pebbles, dropping one into a jar each night the moon clears the ridge. A fisher on the Atlantic watches the morning stars climb, setting nets only when its angle matches a notch he can touch with his thumb. None of them talk about nanoteslas. They talk about promise. The day the beam reaches the backstone, the week the winds usually turn. What nobody knew at the time is how these habits harden into institutions. Counter becomes a role, then a lineage. The person who keeps the rope with knots, the measure of the avenue, also keeps the songs that carry the sequence of days. In Brittany, a standing stone gets a carved groove so children can test a stick for true vertical. In the Andes, a line of posts is tended like a communal orchard, straightened after storms, re-anchored after frost heaves. The work is maintenance, not miracle, and that's exactly why it lasts. Meanwhile, stories accrete around the practice, not to mystify it, but to move it through generations. A serpent of light that coils at midsummer is a way to tell a child where to stand. A tale about a sleeping sun waking behind a door in winter is memory with a handle. When the sky grows noisy, auroras where they don't belong, more lightning, you don't add prophecy, you add redundancy. 2 sightlines, not one. A lunar check against a solar rule. If both agree, you act. If they disagree, you wait. Microstory. A keeper in a windswept Irish valley walks the perimeter before dawn, feeling the posts, checking the lashings, clearing the slit in a low stone. She knows the village is thin on grain. If the midwinter beam finds the backstone, she'll tell them to begin rationing for the climb out. If it misses, they'll hold the ritual anyway, but quietly, and she'll send 2 runners toward the coast to barter fish. The beam arrives. The cheer is small and real. Decisions align with light. From their perspective, these roles aren't elite. The watcher's authority rests on being right in public. If the beam misses and she pretends it didn't, the village sees. That's the pressure that keeps the habit honest. From ours, it's a governance model built on verifiable cycles. Today's equivalents are the grid operator posting load curves, the space weather desk publishing KP indices, the mission controller announcing a safe mode entry and exit over the South Atlantic dent. The tone is the same, calm, specific, accountable. Meanwhile, apprenticeship turns into architecture. Watchers start with sticks and sightlines, then ask for permanence. A slate with scratches becomes a lintel with drilled portholes. A ring of posts becomes a ring of stones when timber rots one winter too many. When a corridor proves better than a notch, they rebuild in stone to freeze the geometry. It's not grandeur, it's fatigue turned into design. I'm tired of readying this rope. Give me a lintel that won't sag. Impact reaches beyond timekeeping. Communities that trust their keepers weather lean years with fewer fractures. Fewer scapegoats, fewer desperate migrations, more coordinated shifts in work and worship. The watchers. Calendar becomes a civic spine. Market days tied to moon phases, repairs scheduled for dull seasons, feasts pinned to beams of light the whole town can witness. That's resilience disguised as celebration. And here's where the past touches our present without strain. We already have watchers, flight surgeons counting dosimeter clicks over the anomaly, satellite operators logging safe mode minutes, forecasters aligning solar wind data to grid advisories. We just hide them behind dashboards. The ancients put theirs in plazas. Maybe that's the adjustment we need. Make the checks visible. Teach the stance. Let a teenager hold a notebook at dawn and say, in front of everyone, the mark was true. When the air feels wrong, that simple sentence carries a town farther than any headline. Preparedness without prophecy. Practical steps for a magnetic rough patch. We don't need omens. We need habits. The cowries rings and the satellite's nap schedules point to the same lesson. the approach hurts more than the flip. So prepare for friction, not fireworks. Think like a builder who cuts a slit to catch midwinter light, and like an operator who safes a payload over the dent. Quiet steps, repeated until they feel normal. Start at the neighborhood scale. Put a solstice line in a public place, a shallow groove or a brass inlay aimed at midsummer sunrise and midwinter sunrise, with clear markers anyone can use. Teach kids to check it. Post the date and a simple instruction. Stand here at dawn. If the sun hits the line, the year has turned. Add a lunar marker nearby. 2 posts sighted to the moon's northern extreme during the standstill year, with a plaque explaining the 18.6-year rhythm. You just built a public clock that doesn't blink when the grid jitters. Next, tie behavior to space weather advisories. Subscribe your town to geomagnetic alerts, the same feeds grid operators watch. Publish a simple playbook. On high-index days, schools move outdoor activities under shade, small airports plan for radio noise, volunteer groups check on vulnerable neighbors who rely on medical devices during power flickers. Keep it boring. The watcher's voice works because it's calm and practical. Now the grid. Utilities already game out heat waves, fold geomagnetic storms into the same routine. Install real-time transformer monitoring where it matters. Pre-plan controlled load-shedding windows that can be announced like weather advisories, with neighborhoods rotating through brief, predictable reductions instead of surprise blackouts. Map critical services, clinics, water pumping, traffic control, and harden them first with surge protection, isolation transformers, and on-site storage. Share the list with the public. Transparency invites preparation, not panic. For households, think layers. A modest battery that carries lights, communications, and refrigeration through a short outage. Surge protection on critical appliances. Shade structures or trees that knock down UV and heat while cutting peak cooling loads. A radio that can bridge a few hours of noisy networks. This isn't bunker gear. It's a cushion against chronic bumps. In the air and at sea, treat polar reroutes and HF noise as seasonal patterns that will visit more often. Airlines already detour on bad days. Make those decisions faster with joint desks where space weather and operations sit side by side. Fishing fleets and small craft can carry simple auroral and radio forecasts, paired with old skills, sextant practice, paper charts, that get rusty until the day they save a trip. Not romance, redundancy. Satellites won't stop napping over the dent, so invest where the naps hurt least. Spread constellations so passes stagger over South America. Design instruments with graceful degradation modes that deliver lower-rate data instead of none. Prioritize radiation-hard memory and robust error correction, even if it costs payload mass. Share safe mode profiles openly across agencies and companies. The sky doesn't care who built the bird. Data users can prep, too. Climate teams and weather centers should treat South Atlantic gaps as a permanent feature. Build assimilation pipelines that expect blank strips and wait surrounding passes intelligently. Fund cross-calibration between missions, so one instrument's nap doesn't erase the whole picture. Archive the gaps visibly. Pretending they aren't there just shifts the uncertainty forward. Cities can stage their own rituals of resilience. Set solstice gatherings at the public line, yes, and pair them with preparedness fairs where grid operators, forecasters, and mission folks show their dashboards. Let people see the nap schedule maps, the transformer monitors, the auroral index. Put a teenager at the mic to call the beam. Make the watchers visible again. When the air feels wrong, familiarity with the practice will matter more than memorized facts. Healthcare systems can write small, high-impact playbooks. Radiation therapy supply chains need slack. Alternate routes for isotopes, redundant suppliers, on-hand buffers for critical meds vulnerable to temperature swings during short outages. Electronic medical record systems and imaging suites should have documented, tested downtime procedures. Rehearsals reduce fear when screens flicker. Agriculture still starts with sunlight angles and soil. Extension services can revive phenology, planting by observed first leaf and bloom, alongside date-based calendars. Promote shade cloth and UV-resistant varietals where appropriate. Encourage water capture and windbreaks because more lightning and storm lines mean more sudden, localized damage. Farmers already talk in risk. Give them fresh baselines tied to cycles, not speculation. Education can seed the habit early. Fold space weather into Earth science classes. Let students build pinhole solstice markers and small radio receivers that hiss when the ionosphere is rowdy. They'll carry that sense of the sky into adult choices, where to put solar panels, when to expect navigation quirks, why the weather map sometimes lies while the horizon doesn't. And policy? Keep it unglamorous. Fund long-life satellites like ESA's Swarm or its successors that watch the field evolve. Upgrade ground observatories, keep models open. Create modest grants for civic sky instruments, solstice lines, horizon towers, library installations that any town can adopt. Require resilience audits that include space weather alongside heat, flood, and fire. None of this is costly compared to the price of chaos cleaned up late. We don't need to forecast a flip. We need to plan for more naps, more reroutes, more days when the aurora shows up uninvited and the radios get cranky. The ancients left us a template. Public clocks that keep working when the air feels wrong, paired with rituals that make the check unforgettable. Our version adds dashboards and firmware. Same habit, new tools. Keep the beam honest. Keep the procedures handy. And when the dent slides under our orbit again, do what good watchers always do. Say what you see, then act like you meant to. What the stones truly say, meaning without myth. So let's strip it down to what survives hard scrutiny and still feels human. The stones don't whisper secret yard lengths or map hidden continents. They say something quieter and more useful. We watched together, we agreed on cycles, we built shapes that remember. Meaning without myth lives right there. Start with 3 sentences carved into practice. 1. The year has edges you can catch with geometry. 2. The moon has a long breath you can count if you're patient. 3. When the sky gets noisy, precision hides in narrow paths and repeatable checks. That's not a priesthood talking, it's neighbors agreeing on where to stand. Meaning shows up in how these places choose truth over spectacle. A corridor that lights for 6 minutes each midwinter isn't trying to awe, it's trying to be falsifiable. If the beam misses, everyone sees. That public test is the point. It pulls trust out of the fog of authority and sets it on stone, where it either lands or it doesn't. The watcher's reputation rides on outcomes, not on stories. Meaning also lives in redundancy. A circle that nods to the solstice and a sight line that catches the lunar standstill aren't 2 decorations. They're 2 clocks that cross-check. If both say now, you move. If one lags, you wait a day. That's how you avoid panicking during a bad season. It's also how you keep a ritual honest when a charismatic leader wants to call time early. Meanwhile, there's humility built into these plans. Builders accept drift, precession, soil creep, frost heave, and design for maintenance. Grooves deepen with use, posts get reset, thresholds get shimmed. Perfection isn't the aim, continuity is. A form that can be repaired by the hands that use it outlives dynasties. That's meaning as governance, durable chores replacing fragile glory. Now add ethics. When a time anchor is public, it resists capture. A king can't hoard sunrise. A temple can't hide a solstice beam that either hits or misses in front of the village. The architecture enforces accountability. That's not romantic, it's structural honesty that many modern systems would envy. Meaning without myth also refuses the comfort of prophecy. The stones don't predict flips, they normalize vigilance. Check the line. Count the nights. Wait for the beam. Those sentences don't sell books, but they carry households through uncertain years. They say, if the air feels wrong, your behavior should get boring, not theatrical. Move work to the cooler hours. Stage repairs after the equinox. Spread risk across microclimates. Keep the instruments simple enough that a child can run them, because a child will someday have to. Microstory. 2 teenagers in a coastal town unlock the plaza at dawn. They chalk the solstice groove, sweep a slit free of sand, and check a laminated card. Sunrise azimuth tolerance notes from last year. One reads the horizon, the other calls the mark. The line glows. A cyclist stops, watches, nods. No speeches, no incense. Just a public truth that anyone can verify before coffee. What nobody sees, because quiet doesn't trend, is how this practice catches other mistakes. A misset clock tower gets corrected because the plaza line shames it. A school's field day plan shifts because the forecast looks fine but the index says the ionosphere is cranky, and the habit says indoors on high KP. A grid operator adds margin because the aurora, weirdly, is forecast for latitudes that never see it. The stones, literal or revived in steel and brass, become a hinge where small civic decisions line up with slow realities. Meaning shows up in how we respond when instruments fail gracefully. A. Satellite naps over the dent. The plaza still tells the truth about the day. A data gap opens. The market waits an hour because the watcher hasn't called the beam yet. That substitution isn't nostalgia, it's risk diversification. It says we value two independent channels, one silicon, one stone, because the world is lumpy and our needs are steady. And meaning, finally, is a posture. Curiosity over certainty, maintenance over monument, cycles over slogans. The builders didn't chase legends about buried codes. They cut slots, set posts, and invited everyone to watch the world keep its promises. If there's a blueprint, it's this: make truth public, make it verifiable, and make it beautiful enough that people will show up to check it. That's the thread the ancients left us. Not a secret ruler, but a public habit that holds under noisy skies. The field may weaken, the dent may drift, but truth still crosses stone at dawn. If this resonated, join the watchers, subscribe, share the story, and add a solstice line to your town. Then watch our next film, where we follow the operators threading satellites through the dent in real time, and show how a plaza groove and a flight rule speak the same language.